Good morning.
Good morning, ma'am.
We are going to discuss, last class we have seen about nucleophilic substitution reaction. Am I right?
Yes.
So I will tell you how to remember this SN1 and SN2. Okay. So I'll give again we will revise what is SN1 and what is SN2. So SN1 reaction means it comes under the category of aliphatic nucleophilic substitution reaction. Okay. So it is, what is that? Aliphatic nucleophilic. You can take your notebook and note it. Aliphatic nucleophilic substitution reaction. So if you take what are the points to remember is, you have subheadings. What is meant by the rate of the reaction, and what is meant by the concentration, what are the factors involved, and what are the examples, and what is its applications. So I'll repeat. You have two categories. In aliphatic nucleophilic substitution reactions, we are going to substitute a functional group with another functional group. Okay. So for example, we have like alkyl halides. The substrate is alkyl halide. So substrate is, what do you mean by substrate means? It is a compound where the reaction takes place. That means it is a place where the reaction takes place. So the substrate is the main reactor. So I will start with an example. You have two categories. One is SN1 and SN2. So we will revise like this. One indicates unimolecular. One indicates what? Unimolecular. The N indicates nucleophile. N indicates nucleophile. S indicates substitution. S indicates what? Substitution. So it is unimolecular nucleophilic substitution reaction. So we will start with an example like alkyl halides. In alkyl halides, you have primary, secondary, tertiary. You have main reactant is primary, secondary, tertiary. So it is generally notated as RX. R is the largest part, the alkyl part. X is the halogen part. So I will repeat. R is the alkyl part and X is the halogen part. Okay. So we are taking unimolecular means it goes with tertiary first. It goes with tertiary alkyl halides. That means we will start like this. In the three sides, the central carbon is connected with three carbons. That means one carbon, are you able to see? One carbon, it is connected with first carbon, second carbon, third carbon. So when a carbon is connected by three sides with another carbon, it is called as tertiary. And this is halogen. This is the halogen. We are going to replace this halogen. Imagine these are our big groups. Alkyl groups or bulkier groups. Alkyl groups are bulkier groups. So you are going to do a substitution. So this halogen is called as the leaving group. The halogen is called as what? Leaving group. So when this leaving group is going out, it has the property of taking away the electrons. The bonding electrons will be taken up by the halogen. So what is the first step is, there are two electrons in the bond. The two electrons are taken away by the bromide. So what is the first step? Step 1 is formation of carbocation. What is the step 1?
Formation of carbocation.
Since it is tertiary, it is called as formation of a tertiary carbocation. Okay. So it is C. Cation means positively charged. Cation means what? Positively charged. Why it is positively charged? Because it is electron deficient. Because it is electron deficient. So the halogen is taking away the bonding electrons. It forms the reactive intermediate tertiary carbocation. This is step 1. What is step 1?
Tertiary carbocation.
So you have to write like this. So this carries marks. What is the first step? Formation of carbocation. Then N3 of nucleophile. The next one is N3 or incoming nucleophile, that is hydroxyl group. incoming nucleophile is hydroxyl group. So the carbocation is formed, step 1. Next is formation of the product. So the OH minus will enter the carbocation and you will get tertiary butyl. So what are the two things we have seen is step 1 is formation of carbocation, step 2 is formation of tertiary butyl alcohol. Okay. Now we will continue with this revision once again. Okay.